Welcome again to Carpenter example, and here we have our silicon wafer with a laser that runs across the surface, and the laser runs back and forth while the silicon wafer rotates at 10 RPMs. And we need to find out the average maximum and minimum temperatures. Also, we would like to know the peak temperature difference across the wafer. And all these will be done from a time step of 0 to 60 seconds. So we'll have all of our data between 0 to 60 seconds, and we can analyze these. How we are going to do this? We're going to use COMSOL and get this done. Before we dive into that, we need to just run through our global definitions parameters, and the most important thing here is the expressions. So we need to carefully input the expressions. We need to give them a name, and the description not really needed, but it's good to put in a description, so if you go back to these at a later point, you'll know what each expressions are. And also we need our definitions variables, and just like what I explained before, the expressions are the key. And I'll provide these in a Word document, which I'll put in the description below. So now let's jump over to COMSOL and get this done. Now we have COMSOL open, so let's navigate to our model wizard, 3D. Now we go to heat transfer in solids, add. Let's wait a bit, and once that's added, that's our physics. We need to add a study, and we need to add a time dependent study, and then click done. This will take a few seconds, so let's exercise some patience. And now, as I mentioned, our global definitions parameters, and also I mentioned our definition variables. Okay, so here I have a Word document that I've put these together. So I provide this as mentioned in the description below, and you will get all your needed values for these two tables. So let's go to parameters, and this is under global definitions, and let's input our values. So we have to be careful when we are inputting these expressions. The name, you can name them many things, so I'm going to call this one r underscore wafer, which is the radius of the wafer, and our expression is 1 inch. And once you click here, as you can see, it automatically converts this. Okay, and description, call this wafer radius. Okay, and then you click in the next one, and then you can continue. So follow the Word document and input the global definitions parameters. So I'm going to pause the video here and input all the others, and then we'll continue. Now we are finished with setting up our parameters. We need to now create our silicon wafer. So how do we do this? Let's go over to geometry. So you can get geometry from the ribbon. So let's click on geometry and let's go to cylinder and let's go to radius, and here we already set up our parameters, so we type in name of the parameters here. So this will be r underscore wafer, which is the radius of the wafer, and the height will be the thickness. And now let's go to block, and for the width of the block we're going to make it 2 times the radius of our wafer, and for the depth it's the same, so you can copy this. And for the height, of course, thickness. Okay, now let's go down to position, and for the X field we want this to be minus 0.95 and multiply that by the radius of the wafer. And for the Y, we want this to be minus the radius of the wafer. Okay, and let's go to geometry and let's go over to booleans and partitions, and let's click on intersection and click inside the graphics, Control A, and then click build all objects and zoom to extents, and this is our silicon wafer. Now let's go down to setting up our definition variables. Okay, so how do we do this? We go to definitions, right click, so click on definitions in our model builder, right click and click on variables, and here we'll input our definition variables as shown in the second table of our Word document. So I'll go ahead and pause the video here and input these, and you can do the same as well. Once done, we need to now go to our home toolbar and let's set up a waveform. So let's go home and let's go to functions, so chop down functions, and we need to add a local waveform. So we have global and we have local, so let's click the one under local waveform, and for the function name, let's give this a name and let's call it triangle. And from the parameters type, there is sawtooth, sine, square, and let's click on triangle. And for the smoothing, we don't need any smoothing. For the duty cycle, it remains default. Angular frequency, let's make that 2 by pi. And phase, let's make that pi over 2. Okay, and let's click on plot. And here is our waveform. With that done, let's go to our definitions, and we need to add some maximum, average, minimum, and global probe, as well as a rotating domain. Okay, so now that we have got that done, let's go to definitions in our toolbar, and let's go over to probes, and let's add a domain probe, and we're going to call this maximum. And for the variable name, let's call this tmax. Okay, and for the type, let's click this little arrow and let's select maximum. Okay, and let's repeat the process, and we're going to create another domain probe, and we're going to call this one average. So let's give the variable name as t average. Okay, and let's leave the type as average because that is what we need, and also let's name it average up here. And now let's create another domain probe, and this one will be for the minimum. And call this one min, and of course here we need to select the minimum. Now let's go to probes again, and this time let's add a global variable probe, and let's change the name, so you can just leave this as global variable probe. If you want, you can change it, but our variable name, let's call that t underscore diff, which it stands for temperature difference. If you want, you can just say t diff, your choice. And for the expression, we need to minus the minimum from the maximum. Okay, so for the expression, we have tmax minus tmin. Okay, and we also need to add a moving mesh. So let's, in the same definitions toolbar window, let's go to moving mesh, and let's add a rotating domain. And for the rotating domain, let's come to the selection, and let's select all domain. And for the rotation, let's come here and let's choose specified rotational velocity. And now for rotational velocity expression, let's change this to constant revolutions per time. And for the revolutions per time, let's call that Well, it's for velocity and rotation. Remember, we give this variable name in our definition. Well, that's why they are important. So you set them up and then you just input the names where you need them. Hence, I said it's good to remember what you name them. And now that we have this done, we'll now set up our physics or heat transfer physics. Now that we have this, let's go over to heat transfer in solids, right click and add a heat flux. And we need to select our boundary, we need boundary 4. The best way to do this is next to modeler, you shall have selection list and you can select your boundaries from this. The default in COMSOL, you won't see this, so if you don't have this option, you can go home, go to Windows, and then you can click on selection list and it will come here. Alright, so now let's click our boundary 4 and add it. And once we have that added, we need to add some calculations. Okay, so we need to add our calculations in our heat flux. And remember our parameters, emissivity, right? So we'll multiply that by heat flux. Well, we name it flux. So, okay, so multiply the emissivity times flux. And that is done there. So we need to go to our physics toolbar and go to boundaries. And we need to add surface to ambient radiation. So select that. And let's go down to surface to ambient radiation, and it says from material, let's change that to user defined. And of course we need to add a boundary. What boundary? 4 as well, and add, and also surface emissivity, we need to add what? Remember in our global parameters here, emissivity, well, let's go back to our surface to ambient radiation. So we need to add this here as well. Okay. Now we need to add a material. We are going to test the heat across the surface of a silicon wafer. So what material do we need? Silicon. So let's go to our Home tab and let's go to Add Material. Now we have this window that pops up on the right hand side of the screen. And let's go to Built-in and let's go down and find silicon, which is here, and then let's add to component. Now that you see it here, you can just click add materials and it will close our window over here. And if you click on materials now, the X will go away. Okay, and if you click on silicon, and you have all the properties of this material here. We leave them as default, we won't trouble those. And with all this done, let's minimize these a little bit. So let's minimize our definitions, our geometry, our materials, and also we can minimize our heat transfer physics. And let's go over to mesh, and let's add a swept. And inside this, let's expand the sweep method, and for face meshing method, which is here, face meshing method, let's change this to triangular, generate prisms. Okay, and that is done there. Let's go to swept in our model builder window, right click on that, and let's add a distribution. And for the distribution, let's locate the number of elements, and we don't need 5 elements, we need 1. And let's go over to our model builder, and let's click on size, and for the size, let's change predefined from normal to fine. This will take a little longer to calculate, but our results will be more accurate. And let's go to build all, and now our mesh is generated. So we have, thus far, we set up our global parameters, we set up materials, we set up our definitions, variables, of course we created our geometry, and we created our physics, and we generate our mesh. Now with all these done, we need to do a study. Now let's go down to study so we can make this a bit clearer by closing the mesh. So here is study. Let's go to time dependent, and let's go down to our range, because we know that we're going to work in seconds as mentioned in the introduction. So seconds, and for our range, start at 0 and then 1 and then what, 60. Remember, it's from 0 to 60 seconds. Okay, so that's our range. And for the tolerance, let's change that to user control, and this will be, I think it's 0.001. Now we have finished setting up our study, so now we need to compute. So let's compute, and this will take a little while, so just be patient. I'll pause the video here, and once done, we'll continue with our results. Now our computation is finished. This is a brief look of our results, but firstly, let's go to results, datasets, study 1 solutions. So click on that, and let's change the frame. So we have the settings, solutions. Under solution, let's change the frame to spatial XYZ, and let's go down to temperature, and let's change the frame to spatial XYZ as well, and you can now click on plot. Okay, yours your default might look like this because this is at 0 seconds. And if you click next, that's 1, 2, 3, 4, etc. And if you want to go back to the beginning, you click here. If you want to go to the end, which we need, you click here. So you can just use these to examine your results. Okay. And with that done, let's go to isothermal. So let's go over to our isothermal contours, and here we have our results as well. Now let's go to probe plot group 3. So let's click on that, and let's go down to our legend and position. Let's move this to our upper left, and let's go back to the top. So that is okay. And let's select our probe plot group 3 and drop down the arrow, probe plot table, and here let's select temperature maximum, hold shift and select minimum, and let's leave out the Tmax minus Tmin, which is temperature maximum and temperature minimum, and let's hit plot. Okay, and this is a graph showing the differences between the maximum, the minimum, and the average temperatures across the surface of our silicon wafer. Now we want Tmax minus Tmin on a separate graph. Okay, so let's go home and let's go add plot group. And what do you want to add? I want the plot group. Okay, and in this 1D plot group, let's change the name from 1D plot group to probe plot group. And let's now go over to our, if you click outside, let's go over to probe plot group, which is what we just named this. And let's right click and let's choose table graph. And inside of table graph, we need to change our plot columns to manual, and now we have the option to select what we want. So what we do we need now is just Tmax minus Tmin, and then hit plot. And here we have our table showing our maximum temperature minus our minimum temperature. After study, we set up our data sets. Study 1, we change the frame to spatial XYZ, and then once we completed that, we repeat the process for our temperature. Okay, and we also have our isothermal, and we have our probe plots. So this one shows the differences between maximum, minimum, and average, and we also have one showing the maximum minus the minimum temperatures. So you can go ahead and analyze all your results, and that's it for this COMSOL tutorial. Bye for now. Take care.